Hello everyone, I am Anjana studying MCA from the Department of IT and today I will be presenting my seminar on Introduction to Compilers with a focus on lexical analysis. The compiler is a very important part of programming languages. It converts high level code into machine understandable code. In this presentation, we will go step by step understanding what a compiler is, what its phases are, and then exploring in detail how the lexical analyzer works. A compiler is basically a program that takes another program as input. The source code written in high level language like C or Java and produces the equivalent machine code as output. It doesn't just translate directly, it also checks for errors and optimizes the code for better performance. Without a compiler, we had have to write programs directly in binary or assembly language, which is very difficult. So the compiler is a bridge between human language and machine language. The process of compilation is divided into six logical phases, each performing a specific function. The front end, including lexical, syntax, and semantic analysis, deals with understanding the meaning of the source code. The back end, including optimization and code generation, focuses on producing efficient target code. These phases are interconnected, and errors are detected in the early stages prevents later ones from even starting. Among them, the first phase, lexical analysis, is responsible for scanning the input text and breaking it into manageable pieces. In the second phase, syntax analysis, it analyzes the syntactical structure and inspects if the given input is correct or not in terms of programming syntax. It accepts token as input and provides a pass tree as output. It is also known as parsing. In the third phase, a semantic analyzer defines the validity of the pass tree and the annotated syntax tree comes as an output. Now, intermediate code generator develops three address codes. In code optimization phase, it produces streamlined code from the intermediate expression. And the final stage, the code generator helps in translating the intermediate code into the machine code. It selects and allocates memory spots and registers. The symbol table is mainly known as the data structure of the compiler. It helps in storing the identifiers with their name and types. It makes it very easy to operate the searching and fetching process. The symbol table connects or interacts with all phases of the compiler and error handler for updates. It is also accountable for scope management. It stores the literal constants and strings. It helps in storing the functions names. It also prefers to store variable names and constants, and it stores labels in source languages. Introduction to lexical analysis. Lexical analysis is the initial stage or phase of the compiler. This phase scans the source code and transforms the input program into a series of tokens. A program that executes the process of lexical analysis is called a scanner, tokenizer, or lexer. It is the interface between source program and parser. The lexical analyzer acts as the eye of the compiler. It reads the source program one character at a time and groups these characters into logical units called tokens. Lexical analysis is also called scanning. For example, the line int sum equal to a plus b will be broken into 7 tokens. The keyword int identifiers sum and a and b, operators, and a semicolon. It also discards unnecessary elements like comments and extra spaces, ensuring that only meaningful symbols are passed to the parser. This makes the parser's job much easier and faster. What is a token? A token is basically the arrangement of characters that defines a unit of information in the source code. Each token belongs to a class that defines its meaning. For instance, keywords have predefined meanings in the language, while identifiers are user defined names. Every token has a token name which specifies its category and an attribute value which points to more information, like the actual name of the variable in the symbol table. Tokens are like the words of the programming language. They form the vocabulary used to write a valid program. Role of lexical analyzer. The lexical analyzer performs several roles. It acts as the interface between the raw program and the syntax analyzer, ensuring that the parser receives a clean tokenized input. It also interacts with the symbol table to store and retrieve variable names and other identifiers. If it encounters any unrecognized symbols or illegal identifiers, it reports them to the error handler. Essentially, it ensures that the input to the next stage is both clean and valid. Lexical analysis has to access secondary memory each time to identify tokens. It is time consuming and costly. To speed up processing, the lexical analyzer uses input buffering. So, the input strings are stored into a buffer and then scanned by lexical analyzer. Lexical analyzer scans input string from left to right, one character at a time, to identify tokens. The idea is simple. Instead of reading single characters, we read large blocks of data into two alternating buffers. While one buffer is being processed, the next buffer is filled from the source file. It uses two pointers to scan tokens, begin pointer and look ahead pointer. Begin pointer points to the beginning of the string to be read. Look ahead pointer moves ahead to search for the end of the token. For example, for a statement into a comma b, initially both pointers starts at the beginning of the string which is stored in the buffer. Look ahead pointer then scans buffer until the token is found. The character blank space behind the token int have to be examined before the token int will be determined. After processing token int, both pointers will set to the next token a, and this process will be repeated for the whole program. A buffer can be divided into two halves. If the look ahead pointer moves towards halfway in first half, the second half is filled with new characters to be read. If the look ahead pointer moves towards the right end of the buffer of the second half, the first half will be filled with the new characters and it goes on. Specification of tokens. Tokens are formally defined using regular expressions. These expressions specify the patterns of characters that belongs to a particular token type. For example, an identifier must start with a letter and can be followed by letters or digits. This pattern can be expressed using regular expressions. Using such mathematical definitions allows us to automate the process of token recognition. Recognition of tokens. Once token patterns are defined, we need a way to recognize them automatically. This is done using finite automata, a simple state machine that moves from state to state based on input characters. When the input matches the pattern completely, it reaches an accepting state, meaning a token has been recognized. Otherwise, if no valid path exists, lexical error is reported. This combination of regular expressions and finite automata forms the mathematical backbone of lexical analysis. Writing a lexical analyzer manually is possible but difficult. To simplify the process, tools like Lex or Flex are used. You simply define token patterns and actions. For example, if you find an identifier, print identifier found, the Lex tool then automatically generates the C code that performs tokenization for you. Many modern compilers use such tools for the front end scanning stage. Error handling in lexical analysis. Lexical errors occur when the input contains characters or sequences that don't fit any valid token pattern. For example, a string literal missing its closing quote or an invalid character like at in a variable name. The lexical analyzer uses simple error recovery techniques to continue scanning instead of stopping completely. It might skip over the problematic area, replace a symbol, or insert what seems to be missing. This helps the compiler provide more helpful error messages. To summarize, we have seen that the compiler is a translator that works in several stages, and the lexical analyzer is its very first step. It reads raw source code, removes unnecessary parts, and produces meaningful tokens. With the help of regular expression and finite automata, it can automatically recognize patterns. Finally, tools like Lex make the implementation easier. Without lexical analysis, the compiler cannot even begin the parsing stage. That's how essential it is. Thank you.